This is lesson 4.1, which is solving systems of equations by graphing. Our essential question is, how can you use a graph to illustrate the solution to a system of linear equations? So our first example is, what is the solution of the system of equations? So we are going to use a graph. So I'm going to draw my x and y axis. Okay, so I'm going to use a different color for each one here. So let's make this top one red. Okay, so we always start with the y-intercept. So you notice the y-intercept there is -4. So 1, 2, 3, 4. I'm going to put a dot at -4 on the y-axis. And then my slope is -2, and we can turn that into a fraction, -2 over 1. So that means I'm going down 2 to the right 1, down 2 to the right 1. And then sometimes what I like to do, especially here where it's almost off the graph, you want to work backwards. So I'm going to go up 2, back 1, up 2, back 1. Okay, because the more dots I have, the better my line, especially when I'm doing this online like this. Okay, so there's my first graph, my first line. And I'm going to use blue for the second one. So we have 0.5x as a slope. We know 0.5 is the same as 1/2. So I'm going to rewrite this as y equals 1/2 x plus 6, because sometimes having the slope as a fraction helps us. So this one we start with the y-intercept, which is at 6. So I go up to 1, 2, 3, 4, 5, 6. I'm going to put a dot. And then my slope is positive 1/2. So I'm going to go up 1 over 2, up 1 over 2. Now again, I'm going to go down 1, back 2, because that's going to help me get a big picture of what my graph looks like. Okay, so there's the second line. So what we're finding with systems of equations and these graphs is we want to find the intersection point between the two lines. So if you look, they intersect at that point right there. And the point would be -1, 2, 3, 4. So -4 in the x direction, and 1, 2, 3, 4, +4 in the y. So my solution to this system is -4, -4. So that's what we're finding. We're finding the point where the two lines intersect. Okay, so this says, what is the solution to the system of equations? Use a graph to explain your answer. So this is going to be, we're going to do this similarly. So let's get our x and y axis for both of these. Okay, so I'm going to start with, let's start with this top one. I'll make red. So 15x plus 5y equals 25. That is in standard form. So I can use the cover-up method. So if I cover up the y, I have 15x equals 25. So 25 divided by 15 is 1 2/3. So I'm going to go over 1 2/3 in the x direction. Okay, and then if I cover up the x, 5y equals 25, so y would be 5. 1, 2, 3, 4, 5. So this line right here is my first one. So then I'm going to graph, let's graph this one in blue. So the second line, I might want to rearrange it and write y equals -3x plus 5, because it's easier to graph when we remember slope-intercept form. So we're going to start with 5, so I'm going to put a dot up here at 5, and then we're going down 3 over 1, down 3, 1, 2, 3 over 1. And my graphs aren't the best because this is hard to do online, but you can see they are the same line. So what we would say for this one is we would say infinite solutions, because if you're looking where the lines touch, they touch everywhere. So that's an example of infinitely many solutions. Okay, let's look at the next one. So I'm going to use red for this top one, and I'm going to rearrange it. So I'm going to make it y equals, I'm going to add the 2x to both sides, so it would be positive 2x plus 6. So we're going to go to 1, 2, 3, 4, 5, 6, and we're going to go up 2 over 1, or down 2 back 1. So there's my first line. Then I'm going to use the cover-up method for the second one. So we'll do this one in blue. So if I cover up the y, I would have negative 4x equals 8. So x would be negative 2. And if I cover up the x, I would have 2y equals 8. So y would be 4. 1, 2, 3, 4. And we graph those. You'll notice that those are parallel. So just like we've talked about before, so those are parallel, they're never going to cross. So in this case, we would say there is no solution. Since for the systems, we're trying to find where they intersect. So if they intersect in all spots because they're the same line, then it's infinite. And if they don't intersect at all, then it's no solution. Okay, so our last example here is what is the solution of a system of equations. So sometimes you graph. So let's sketch what this would look like here. Oops. Okay, so let's sketch. So if I go, so for the top one, let's use red. Okay, so I go down to negative 3. My slope is up 2 over 1. So there's my first line. And then we'll make this one blue. So I'm going to go up to 6. 1, 2, 3, 4, 5, 6. And I'm going down 5 over 1. 1, 2, 3, 4, 5 over 1. Okay, so there is my second line. So if you look at this, you might notice that we can see where they intersect, but it's not on a nice corner point like the first example we did. So sometimes we have to use technology to help us approximate the solution. So see how it says solve solutions approximately. So one thing that I'm going to show you, so you could go to www.desmos.com. So this is a free online graphing calculator. I'm going to show you the app. It's also free. So if you have a phone or a tablet that you could download the app to, that's another option. So I am going to go show you on the app. So here's the Desmos app. So what I could do is I can go y equals, I'm going to type in my two equations. So 2x minus 3. Then I'm going to make another line and do y equals negative 5x plus 6. Okay, so this looks like our graph that we just did. But the nice thing about Desmos here is you'll see there's a little dot right there where they intersect. You can click the dot and it will tell you this approximate solution. So you can see right there, they cross at 1.286, negative 0.4229. So this is something, even when you're doing ones that are not approximations, you could graph them to make sure that you are getting the correct answer. So Desmos is a good option for checking your work and trying to figure out where they crossed using a graph. Okay, so let's go back to our thing here. So we found that they intersect at 1.286, negative 0.429. So that is our solution point. Okay, let me know if you have any questions.